Oh, good afternoon. This is Mr. Precella again. We were interrupted in our discussion on slopes. I think we were ready to look at problem number 5. I just finished saying that we can analyze a graph and determine the slope of a line using the concept of rise over run, and we're looking at number 5, where they ask us to find the graph of this line. The slope of the line. I'm going to draw this line because I want something to point at and to be marking on. So here and right here. Even when I had the grids, to switch over to my writing. Look at my y-axis. Look at that. Look how, I couldn't stay on that little line even when it was drawn there for me.
This is the neater graph. So it looks like we have a line. And what's the x-intercept here? 2, 0. And this one, the y-intercept is 0, 3. 0, 3, yeah. Okay. So look at Tim's less than neat graph.
Blow it up. Keep on. Now, I think what I like to do, it doesn't matter which point you start at, okay? I usually start at the lower point and work my way to the upper point. Realize we said that the slope is equal to the rise over the run. The rise being the vertical movement, the run being the horizontal movement. Let's start at this low point. What would we have to do to get to the same level as this upper point? Vertically, we'd have to go up 1, 2, 3 to get positioned on the same level. So we'd say the rise is a positive 3. And I'm positioned here where the little x is. Now, the run is the horizontal movement. I'm going to have to move in the negative direction to get to this actual point. So my run is going to be negative. Moving towards the negative direction, how many units will I need to move to get to that actual point? 1, 2. Positive 3 divided by negative 2, that says that the slope is negative 3/2. Go ahead and type that in.
Under what circumstance would you have used answer B?
The slope is undefined. A vertical line, that's right. Okay. Come back to my work. Once more. We could start at the top point. I just start at the bottom point. We had to go in the positive direction, so up 3 units to get on the same level as that second point. Then we moved towards the negative direction, 2 units. So we had a positive 3 over a negative 2. Realize if you had started at the top point and moved down. If you had started at the top point, what would your rise be? Would it be positive or negative? It would be a negative 3. You got that little x there now. Then your run, so your rise would be negative 3. Your run would be positive 2. Negative divided by positive still gives us a negative fraction as our final answer. And remember, one of the first things I said about slope, if the line is falling from left to right, you expect the slope to be negative. Any questions there?
Well, depends on where the points are.
It depends on where the points are.
Like right here. Ooh, let me blow it up. If you had started here the rise is positive, the run is negative. But if you had started at the top point, then the rise would be negative, the run positive, but you're still getting a negative 3 over 2. Positive 3 over negative 2 or negative 3 over positive 2. It doesn't matter which point you start at. You could start at the top one or the bottom one, you'll still get negative 3/2 as the answer. You see, is that answering the question? No, but it's consistent.
You're saying between those two is how much you're trying to get that's how you're getting the rise is how much is in between the two.
Up.
And then the run is
Like
in between the
the
two.
rise
Okay.
and run to the next point.
That makes sense.
Okay.
Okay.
Okay. Something else I want to state now. We don't want to have to, if we want to find the slope of a line, we don't always want to rely on having the graph and counting rise over run. Also, suppose those numbers are really big. Suppose you have the ordered pair 102,79. You don't want to have to plot these points and count rise over run for the ordered pairs to determine the slope. Given two ordered pairs, I bet this is the same notation y'all used the last time. X1, Y1, and X2, Y2. The slope passing through these points, the slope of the line passing through these points is given by the formula m equals, it's a fraction, just like rise over run. The numerator is going to determine the rise. You subtract the y coordinates. Y2 minus Y1, that's giving you the rise. The horizontal movement, that run, you subtract the x coordinates in the same order, x2 minus x1. And, you know, I think I'll go ahead and say that equals rise over run. Y2 minus Y1 gives you the rise of the line. X2 minus X1 gives you the run. Putting those two together, we have what's known as the slope formula. Let's look at number 6. Here they're not giving you the graph. They're just giving you points on the line. And that's one option. You could draw the graph and count rise over run. But I want to illustrate this slope formula. Let me write the problem down. Number 6. And the points are 5, 4, and 9, 7. Okay, let's switch over to my paper. Just like you did with the distance formula and the midpoint formula, I'm going to identify the first point I write down. The first order pair, I'm going to think of that as X1, Y1. The second order pair, I'll think of as X2, Y2. We know the slope is given by Y2 minus Y1 all over X2 minus X1. Here's the minus from my formula, Y2 is 7, so I have a 7 minus Y1 is 4, okay. X2 is, the second X value is 9 minus 5, 7 minus 4 is 3, so we have a rise of 3. 9 minus 5 is 4, for a slope of 3/4. We don't even have any negative signs to mess with here. Positive 3 divided by positive 4 gives me a positive 3/4. Any questions there?
You could graph the line and count, but again, ask yourself, what would you do if this were 50, 40, 90, 70? You wouldn't want to be plotting out 50 units to the right, 40 up, and so forth. So 3/4.
How about number 8?
Yeah. 7 has just positive numbers. I want to do one where there's negative numbers. Number 8.
Okay. Let me write the problem down again. Or not. Okay. Find the slope of the line containing the points -4, 9 and 1, 7. -4, 9 and 1, 7. Switch over to my paper. So, once again, I think of the first order pair as x1, y1. The second order pair, that's x2, y2. And I remember the slope formula. It's written right up there above us if you don't remember it. y2 minus y1 all over x2 minus x1. And these black minuses that I'm writing in there are from the formula.
So it'd be 7 minus 9.
Okay, so we have a 7 minus 9, I agree.
That's switched to
And then it'd be 1 minus -4.
And then we have down here, the x2 is a 1 minus, and what did you say?
A -4.
Okay.
So that would turn it into a positive.
Minus a negative, that turns into a positive. You're right. So we have 7 minus 9, that's a -2, all over. Oh, I forgot to turn on my microphone, didn't I? I was up here grumbling, and I knew that the microphone, when the internet went out for that moment, I was saying some things under my breath, and I didn't want y'all to hear it. So, I turned it off and forgot to turn it back on. Sorry about that. So, -2/5 for a slope. There's none that have any of the special cases. Oh, I'm going to make up one. Okay. I have one I'm going to make up. Okay, I'm going to make up an example. I know y'all love it. Y'all are there thinking, don't do that. Just do the stuff that's not the homework. Why are you doing that? Oh, I just want to keep y'all here longer. That's why. Let's find the slope of the line. Passing through and here are the 2 points. Let's see. -5, 1 and -5, -8. And I'm going to use the slope formula. I remember the first order pair I wrote down I'll think of as x1, y1. The second one I'll write down as think of as x2, y2. And we know that slope is equal to, we have that little slope formula, y2 minus y1 all over x2 minus x1. And These black minuses I'm writing down are the minuses from the formula. Start calling it out for me. What goes here?
Negative 8.
-8, I agree.
Minus 1.
-1, okay. Here,
Negative 5.
-5 minus.
1. Negative 5.
Okay, that's going to become. Okay, well, -8 minus 1, that's a -9. I'll go ahead and write that down. -5 minus a -5, that becomes negative plus 5. And what do we know about a fraction that has a denominator of 0? It is undefined. This is a vertical line. If you graphed those 2 points, it'd be a vertical line passing through -5 on the x-axis. If you use the slope formula with a vertical line, you're going to get a denominator of 0. And we know that you can't divide by 0, so the slope is undefined. Any questions there? Well, let's do writing equations of lines. There are multiple forms that we can use to write an equation to represent a line. There's the slope-intercept form. There's also the point-slope form. There's even this bizarre 2-point form, which is just the point-slope form, but the m replaced with the definition of the slope definition. But what I found is that to write equations of lines, I already know how to write the equation. If I wanted to write the equation of this line here, I know the special cases, vertical and horizontal lines. We said this line is vertical. Imagine drawing it there. Both of the x values are what? -5. So the special numbers, the special lines, their equations are easy to write. If it's vertical, the equation has x and no y. If it's horizontal, where is it? If it's horizontal, I said the equation will have a y and no x. But suppose it's a slanted line. I really don't use standard form for anything. What I do to write an equation of a line, I use what's called slope-intercept form. I'm starting something new here, so let me draw the little green line there. Okay. Let's say, given the slope m of a line and a point, no, that's, just mark all that out. Slope-intercept form. I'm just going to write it out and then identify what the things are. It's y equals mx plus b. Notice we have both x and y, so we're looking at a slanted line, unless the m value is 0, or the y value were to be 0. That m is the slope of the line. This number b tells you where the graph passes through the y-axis. The b is the y-coordinate of the y-intercept. That b value tells you what number on the y-axis does the graph pass through. Now, if they give you the slope and they give you the y-intercept, it's easy to write an equation for the line.
We're not writing equations.
Oh, we're going backwards, aren't we? Yeah. Find the slope and the y-intercept of the line. Here they're giving you the equation. We're not even writing the equation yet.
Find the slope and the y-intercept.
If the equation is already solved for y, the number in front of x is the slope. So negative 5/6 is the slope. This number here is the number that the graph crosses the y-axis at. So the y-intercept would be 0, 8.
Not a lot of work.
If the equation is solved for y, I'm saying it again, the coefficient of x gives you the slope, the y-intercept, the y-coordinate of the y-intercept is that number right there, in this case 8. So,
Touch it in. Slope is negative 5/6. The y-intercept, they already give you the 0, comma.
I wouldn't expect them to keep doing that. I would think they're going to make you type in that ordered pair. I figure this is just the first one we did. Number 10, at least it's already solved for y. I don't think that's going to continue. Switch to my paper.
What's the slope and what's the y-intercept?
Okay, the coefficient of x, that's the slope. Oh, wait a minute. The slope is just the number 1/4, okay? So the slope is 1/4, not the x, just 1/4. What about the y-intercept? You have to write it as an ordered pair, so 0, 9. There it is. Type it as an ordered pair. You see, they're not giving you the parentheses and the 0. You have to type out the whole ordered pair. Same instructions. Find the slope and the y-intercept. But notice, is that equation solved for y? No, it isn't. Let's write it down. That is 7. They want us to find the slope and the y-intercept, but this thing is not written in slope-intercept form. So before you can determine the slope and the y-intercept, you need that y by itself.
So minus 4x.
So minus the 4x to give us y equals a negative 4x plus 7. So once we have y by itself, you can tell me the slope. Negative 4, I agree.
Y-intercept is 0, 7.
Okay, the y-intercept, right, as an ordered pair, 0, 7. I agree. Any questions there? If the equation's not solved for y, you'll need to solve it for y, and I doubt they'll all be that easy to solve for y.
Next one. 7. And what's that? 0, 7.
Mm-hmm. Number 12. Find the same instructions. Find the slope and the y-intercept. But that equation here, 10x plus 5y is equal to 15. Blow it up a little bit. There. I need to get y by itself. What do you think I'm going to do first? I'm going to do the same thing first I did here. Moving that x over, I'll subtract the 10x to get 5y equals a negative 10x plus 15. And then divide by 5. Realize you're dividing across by 5. Every term is being divided by 5 to give us. So we have y equals negative 10 divided by 5. I agree with the negative 2. The x plus 15 divided by 5 is 3. So the slope is negative 2. I agree. Okay, 0, 3. The 3 is used for the y-intercept.
If you find an algebra book prior to the 90s, they used to define the y-intercept as just a number, not an ordered pair.
And the reason they did that is because then we'd be able to say negative 2 is the slope, 3 is the y-intercept. By changing the definition of y-intercept to be actually an ordered pair rather than the number at which the graph passes through the y-axis, that changes how we describe that number there. We can't say 3 is the y-intercept. Well, 3 is the y-coordinate of the y-intercept.
It's one of those rare times that the definition in math changed, in algebra. What did you say it is? 0, 3? Parentheses 0, 3, parentheses. Okay. And now we're ready to start writing those. So at this point, up to this point, we've been given the equations. Now,
this is what I was going to jump to earlier, okay? Now we're going to start writing equations of lines. They're giving us the slope, and they're giving us a point on the line. Is that 0.52? Is that the y-intercept? If you plotted the 0.52, would that be on the y-axis?
no.
No, because if it's on the y-axis, the x value has to be what? 0. So they're not giving us the y-intercept. If you view an example, they're going to be using a special form of a line called the point slope form of a line. That's just a hoax that's perpetuated on the on math students. There's no reason for you ever to need that. You can write equations of slanted lines just using y equals mx plus b. You don't have to remember another formula. Just use y equals mx plus b. Let me write the problem down. We're writing an equation of the line with the slope equal to, what is it? 4. And containing, what's the point?
5, 2.
5, 2. Okay. 4 and 5, 2, yeah. Okay. Switch into my work. Yeah, there. We know the slope-intercept form of a line. Y equals mx plus b. We know the letter m. What number are we going to put in place of that m? 4. So we know the equation is going to be y equals 4x plus b. Did they give us b? No, they didn't, but they gave us an x and a y. This ordered pair here. We know that x can be 5 and y can be 2. They didn't tell us the b value, but they gave us an x, y value. Plug in 2 for y. Plug in 5 for x. We all following what I'm doing? We don't know b, but they gave us an x and a y value. So we have 2 equals 20 plus b. The 4 times 5, that's where I got the 20. I think we can find the b value now. What is it? Subtract 20 from both sides. 2 minus 20, I agree. B is equal to negative 18. So I think we've got the equation. You take that negative 18, that's what's going to be in place of that plus b. So our equation is y equals 4x, and in place of that plus b we have minus 18.
And if you want to see it done another way, look at view an example. I remember we both had different algebra teachers when we were in high school, and this is how my brother's algebra teacher did it. And I remember the first time I ever saw that, I was like, why the heck are we having to memorize y minus y1 equals m times x minus x1, the point slope form? And then, heaven forbid, why did we have to memorize the 2-point form?
I remember looking at that 2-point form from Tony's class. I'm like, this is sheer nonsense, Tony. Y minus y1 equals y2 minus y1 over x2 minus x1 times x minus x1. What are y'all doing? Why do you have all these formulas? But
My favorite answer was because. It's just because.
Just because, yeah.
at least the teacher should say, well, because the coordinating board says you have to have that. So give some sort of answer.
Blame the state of
Blame the
great
state of
Texas.
Blame the great state of Texas. When people complain about what we're doing in class, I say, blame the great state of Texas. They spell it out for us.
So we know how to write the line, or the equation of a line, if we have the slope and an ordered pair. It's got to get harder than that. Oh, I think it just did. Why? It's still the slope and an ordered pair, but what do y'all think is the harder part?
I don't think it's hard.
I know, but what did they?
Oh,
I think the students think. If you had to do 13 or 14, which one do you think would be easier?
Okay.
Probably most people would say 13 because there's no fraction.
Oh my God.
But it's not too difficult doing these fractions. Okay,
Yeah,
so
we'll
this is
see.
the same instructions.
Oh, you're right. So write the equation of the line. They want us to write the equation of the line.
Well, I wasn't telling you to write that, but okay.
We know the slope-intercept form of a line. Y equals mx plus b. And we know what m is going to be. 5, 6. They gave us that. Y equals 5, 6x plus b. Did they give us b? No, they didn't give us b, but they did give us an x and a y value. They gave us an x and a y. So let's substitute in. We'll replace the x with 2. We'll replace the y with negative 3. So we have negative 3 is equal to 5, 6 times 2 plus b. Oh, this is working out nicer than I thought it was going to. Or is it? I guess really it isn't. We're still going to have a denominator, isn't it?
Well, can you not cross cancel?
We could cross cancel the 2 and the with the 6 there, and that would leave us what?
530.
Okay, 2 goes into 6 3 times. So that's not a 36. I better rewrite that. That says negative 3 is equal to the 2 went into the 6 3 times, so we just have 5 over 3 plus b. And I'm going to take an unorthodox approach here. I'm going to eliminate that denominator, okay? I find that when people start having to add and subtract fractions, they mess up getting the common denominator and building the equivalent fractions. So what I'm going to do, how many total terms do I have here? How many do I have on my left, the left side? 1. Over here? 2, so that's a total of 3. Whatever that denominator is, I'm going to multiply every term. I'm distributing 3 over all 3 terms. I'm multiplying all 3 terms by 3.
And all the fractions gone.
Okay, 3 times negative 3 is negative 9 equals, what's about to happen here? Leaving us with, I couldn't hear you. 5 plus 3b. Remember when I say I can't hear you, I just can't hear you, okay?
Isn't this one easier to solve for b
Yeah,
without a fraction now?
what are we going to do to get b by itself? Subtract 5, that's negative 9 minus 5 will give me a negative 14 equals 3b, and then divide by 3 to give me b equals negative 14 thirds. So, in place of that plus b we have there, what are we going to write? Okay, so we have a y, here's our final answer, y equals 5 6x, and in place of that plus b, we're going to have a minus 14 thirds.
So even though the fraction was, the slope was a fraction, it's not that difficult, but I do think it works out. Most students have a better shot at getting it right if they multiply through by that denominator and get rid of that fraction. You agree, Tim?
I agree. Any questions there? It looks terrible now that I
Really
look
does,
at it.
Yeah.
It's just hard to believe those penmanship awards I won.
I know.
And I tell you, 5 6 that's minus 14 thirds. Switch back to my work before we go on.
So
Any questions there?
this is one of those assignments where it builds. The last problem puts the stuff together.
We're going to put stuff together that we've seen. Okay? I heard that. Number 15.
Okay. Last problem. Okay.
Find an equation of the line containing the given pair of points. I believe I'm an optimist. I'll tell you why. I always think no matter how bad the situation is, it could always get worse, okay? And so,
What are you being optimistic about?
because look back at number 14.
Oh.
no matter, no, my word.
Oh, your word.
My word. Okay. Even though we had a fraction as for the slope, at least they gave us the slope, right? They gave us the slope at least. They didn't give us the y-intercept, but they gave us the slope. Look at number 15 now. Did they give us the slope?
Who wants to tell us what we're going to have to do first here?
No.
The x1, y1, x2, y2.
And use the slope formula. We're going to have to find the slope first,
Where's the
okay?
formula?
Where is it? Here it is.
Let me show.
They didn't give us the slope. So they just gave us 2
one
points.
extra step.
We have one extra step. We're going to have to use the slope formula to find the slope. In 13 and 14, they were giving you the slope. But here in number 15, you're going to have to find the slope. And we know how to find the slope. We have our little slope formula. So let me write the problem down. But things could always get worse. At least in the other problems, they were giving you the slope. You didn't have to first use the slope formula. Here, as I look at these problems, this thing, I think, well, the first order pair I see, I'll think of as x1, y1. That's what y'all were saying a moment ago. x1, y1, and x2, y2. We want to find an equation. Let me make a note. That's what we're trying. Our ultimate goal is an equation. And we know we're going to be using y equals mx plus b. But do y'all see the problem? Not only did they not give us the y-intercept, they didn't give us the slope.
But they gave you 2 points, and they
so-
know how to find the slope with 2 points, Tim. Don't make it... I'm optimistic. I think they can do it.
What number's going to go here?
7,
Minus,
4, 4.
okay, y2 minus y1 all over here. x2 minus x1, 6 minus 2. 7 minus 4 is 3 fourths. So now we have the slope. The slope is 3 fourths.
The most basic problem-solving strategy. If you know how to do one problem, we know how to do it when you have m and 1 point. When you're confronted with a new problem, make it look like that other one. So here we have 2 points. Which one of those do you want to use?
You'll get the same answer, but use the first one, the one that has the smaller numbers, okay. Now this problem looks like number 14. We have y equals 3 fourths x plus b.
Let's see, is everyone caught up? Y'all follow our logic?
We're now using this y equals mx plus b. We use the slope formula to find the value of m. Still have to find b. What number am I going to use as x here? 2. Y.
4.
So we have 4 equals 3 fourths times 2 plus b and we can cross cancel. We can cross cancel there. What are we going to get? 3 over 2, so we have 4 equals 2 goes into 4 2 times. I'm going to recopy that. That's 3 over 2. Did you follow me there? I'm going to get rid of the fraction now by multiplying every term by 2. I'll treat that as a 2 over 1 and a 2.
Almost finished.
We're almost finished. 2 times 4 is 8 equals here Okay. Plus 2b there's only one sensible next step if we're trying to solve for b. Minus the 3. 8 minus 3 gives me 5 equals
It would be negative 5 over 2 equals b.
Negative or positive?
Positive.
I'm thinking it's going to be positive, right?
8 minus 3 gives
right,
me
I
a...
was thinking that.
I'm not moving the 8 over to the right. Okay, I'm moving the 3 to the left. 8 minus 3 gave me a 5. Okay, and then divide by 2 to give me b equals 5 over 2.
So do I type 5 over 2 in? Is that the answer?
Is this my answer? Does he type in 5 over 2? Okay, you take that 5 over 2 and you put that in place of the plus b. So you have y equals, here's my final answer, y equals 3/4 x, and that's a positive 5 over 2. Any questions there?
Make sure you don't do that, what I just did.
Would they take it if you did that and put that x in the denominator?
No.
No. Lines do not have variables in denominators.
Gotta go right arrow, x, plus 5 over 2.
Any questions there? Okay.
Oddly enough, this is one of the foundations assignments,
This is
which is irrelevant to y'all.
normally the
Still gotta do
foundation
it.
stuff is just mixed in as you're going through the homework. If you think, oh, this problem seems so easier than, okay, that was probably a foundations problem. It's all blended together. But here, all this material was foundations material.
Now show them remind them on Monday. Well, let me
Monday-
go ahead. I'll just stop the recording.